In this week's lab, we were required to measure the force between two magnets as a function of the separation between their center of mass. To calculate the force, we use the theory of a permanent magnet. A permanent magnet is a dipole, so it has two opposite sides known as the north pole and the south pole. We observe an attraction force between the north and south magnetic poles. However, there is a repulsive force between the same poles, e.g. north and north or south and south. The equipment used in this practical was the following: a retort stand, two magnets, a ruler, a scale, a plastic cup, and some tape. The purpose of this lab was to measure the force between two magnets. This could either be done by using repulsion or attraction on the magnets. In this practical, we use repulsion. We use repulsion because it would be easier to calculate the force between the two magnets by using the following setup. We taped a plastic cup to a scale and put the magnet on top of that, so the magnet doesn't interfere with the scale. We then clamped the other magnet on a retort stand, followed by a ruler next to it. The distance y between the center of the magnets will change by sliding the clamp on the retort stand. Using the ruler, we would be able to measure the distance the two magnets are from each other. For different distances, we can measure the force from the mass given by the scale. To measure the mass, m, we would lower the clamp on the retort stand until we notice the scale given measurement. At this point, we would measure the distance y between the center of the two magnets and calculate the force using the formula F equals ma, where the acceleration is gravity, so the force equals the mass times 9.81 meters per second squared. We then reduced the distance until the scale gave us a reading of null, which meant that there was too much weight on the scale. The scale gave us this reading when the two magnets were less than 2 centimeters apart. Here is the data we collected from 13 different distances. We agreed that the uncertainty in our measurements would be plus minus 0.1 grams. After measuring the mass at 13 different distances, we noticed an exponential change in the mass. To calculate the force at each point taking uncertainty into account, we add 0.1 grams to each mass that we got, then calculated the force. This was also done by subtracting 0.1 to each mass. Then, by averaging the two calculated forces, we get the uncertainty in our force to be plus minus 0.981. After calculating the force, we can see that the force is exponentially increasing as the distance between the center of the two magnets starts to decrease. We get a repulsive response from the magnets due to the magnetic fields. We have a permanent magnet which is dipole. The magnetic field's direction goes outwards on the north side, while the south side goes inwards. So, the magnetic wave produced by a single magnet would look like this. Now, if we take two magnets and put them next to each other facing their opposite pole, i.e. north and south, the north pole will attract towards the south due to the magnetic field. The arrow indicates the direction of the force. We notice that the north pole has arrows going outwards, while the south pole has arrows going inwards, resulting in attraction between the poles. However, if we put the magnets next to each other with the same poles, the magnetic field shows the lines of the force in opposite directions. It's like Legos. If you have two Lego pieces, to connect them, we place the bottom of one piece on the top and they snap on. However, if we place both tops on both bottoms of the Lego, they won't stick on. If we take a look at the graph here, we notice an exponential increase. The graph starts to noticeably increase when the distance is less than 10 centimeters. This is due to the force increasing as the distance between the magnet decreases. This experiment has shown the force between two magnets as a function of the separation between their mass. The objective was to calculate the force between two magnets. This was accomplished by lowering a magnet on another magnet taped to a scale, using their like poles to cause a repulsion, which gave a mass which could be used to calculate the force.